All right, so in example 9, what we are going to do is we are going to find some inverse normal values using percentiles. So the normal model N500, 100 gives a good approximation of the distribution of quantitative SAT scores for college-bound female high school seniors in 2012. A scholarship is awarded to a student who scores at the 96th percentile or above. What is that score? So our 3 steps. Our first step is going to be to sketch our curve. So just like we did with other problems in this section, we're going to use our mean and our standard deviation to label our normal curve. So our mean is 500, our standard deviation is 100, so we're going to add 100 as we go up, and we're going to subtract 100 as we go down. Right. Now we want to shade this in. We're thinking our 96th percentile, so we want to shade in approximately 96% of our curve. So we don't know exactly where this is going to land. I'm just going to draw a line right around here and say that this is going to represent approximately 96%, and we're going to shade then this area to the left of this. So again, where we kind of make our vertical line on our horizontal axis might not necessarily be exact, but we should be able to kind of gauge how much we are going to shade. 96%, we're shading in a large part of our normal curve. You know, if we were doing like 25% or something like that, we'd just be shading in a smaller portion of our curve. Right, so we're looking at 96%. So here is approximately 96% of our normal curve shaded in. All right, now we're told to find the z-score. So what we're going to do is, instead of using the z-scores along the top of the rows and columns, what we're going to do is we're going to look for something that's as close as we can get to 0.9600 in our table. Right? So what we are going to do is we are going to look for 96%. So 0.9600 in our table. All right. Now looking in our table, what we'll see here is on your negative side of your table, you're going to see your percents that are less than 50%. And then on your positive side, we're going to see our percents that are more than 50%. So this is the positive side of that table, our standard normal probability table. And what I have circled here is 0.9599. That's as close as we can get to 96%, because 0.9608 is a little bit further away, right? So this is going to be the value that we're going to use. So using this value, now we're going to find our z-score. So we go over here to the left, we are in a row that starts with 1.7. Going up, we are landing at 1.7, and our second decimal point is 0.5. So we put that 1.7 together with that 0.05. We get z equals 1.75. Right, from the headings of our table. Right, so there's our z-score. Now once we have that z-score, now we're going to convert that z-score to standard units using that formula that we see there. Right, so x, right, is mu is our mean, plus z we just found was 1.75, times sigma, well that was our standard deviation, which was 100. Right, so we multiply this out, and this gives us 500 plus 1.75 times 100 is 175, which gives us a total of 675. Again, feel free to just plug it into your calculator all at once to calculate that value. So what we're going to answer is the 96th percentile is about 675. Right, so that's our score for our 96th percentile. So again, we found our inverse normal value by going through these 3 steps. We sketched our curve, right? We found our z-score using the table, and then once we had that z-score identified, we used this formula to convert our z-score to units.